Trying to find?
Q.
We're trying to find Q. How much heat does it take? That's Q. So we know the heat of fusion. Do we know how many moles of water we have?
Yes, 25.
25. I'm just 25 up here.
Well, you gotta do 450 G over 1
We have to
mole.
convert, don't we?
Yes.
We have to convert.
And then it's water, so it's like 18. Come
Right,
on, Miss
that's
Moore,
right,
you should have
that's
known
right.
that. Honestly,
That's what I
I
have
don't
you
know where
guys
she
for.
is right now. I don't know how she does this stuff.
It's a miracle.
Yep, pretty smart. Pretty smart.
Don't ever think that, oh, he wouldn't make us do mole conversions. Mole conversions are just part of what we do. And so it doesn't matter what topic we're dealing with, you might have to do a mole conversion like we do here. So yeah, you have 450 grams of water, you need moles, so we have to do this. Get into moles of water. Then we can plug that in there. We'll know both of those and we can calculate Q. See that?
Yeah.
So that's, do we do that in our heads? 450 divided by 18?
25.
It's amazing. So it's 25 moles. So the Q is equal to, which delta H do we use?
6.01.
Right, the one for melting, not boiling. 6.01 kilojoules per mole. And then times the number of moles, which is 25.
It'd be about 150.
150? So we can use 3 sig figs. Let's just call it 150 kilojoules. That's not very hard. Does that look hard to you? Pretty easy.
Wait till the worksheet.
Now the next one, when you have 24 moles, that one's gonna get us.
Oh gosh. Anybody have any questions about this?
That's it. Yeah, how good
I'm changing all my problems tomorrow.
I have 6 sets.
So now we're going to be dealing with steam. What do you have to do with steam to get it to condense to liquid?
Boil.
What would you have to do to steam to get it to
You have to
condense?
make it negative.
Do you have to put heat in or do you have to take heat out?
Take heat out, so it
Take
becomes
heat out of it,
negative.
right. We're going to have a negative Q. That's okay to have a negative Q, that just means heat's going out. Q is the flow of heat. Heat's not like a piece of solid or something. It can flow in or out. So if I can erase all of this, let's do this. Now, I didn't give you any notes on what to do with condensation. All I gave you was this. Q of melting equals heat of fusion. I just use FUS for fusion times moles. And Q of boiling equals heat of vaporization times moles. I'm asking you in this problem to condense a gas to a liquid. Are either of these any use for us?
Yeah.
I think they are.
People in-
Yeah. Because condensation is the opposite of boiling, isn't it?
Mm-hmm.
So if we know that water takes a certain amount of energy to boil, that's the exact same amount of energy as steam would take to condense the other direction. Are you okay with that?
So it's just negative.
Boiling and condensation have the same amount of heat, they're just which direction you're going. If it takes 40 kilojoules to boil 1 mole of steam, that means if you have a mole of steam, you would have to take away 40 kilojoules of energy to get it to condense. So, that means this. Q of freezing equals negative heat of vaporization times moles. You don't get that?
Oh, okay.
Okay. Was this problem okay? How much heat it takes to,
I just don't understand the whole part where it goes like
Tubes, come on.
I don't understand
Yeah, this whole fusion thing, this is it's just a constant value. Just like specific heat, you just plug it in for the melting. And then the vaporization, just plug that in for boiling. If I can take you back. And be free, if you wanted to boil 1 mole of the liquid, it takes that much energy. When you have a gas, like steam, and you want to go this way and condense it to a liquid, it takes the same amount of energy to get it to condense, but in this case, you're going the other way. So the number is the same, it's just the sign in front of the number that's different. So you're just going to have to recognize that boiling is this amount of energy in that direction, and condensation is the same amount of energy but going the other direction. So if we can calculate how much energy it takes to boil a liquid, that's the exact same amount of energy but with the negative sign to condense the gas.
So whenever it involves condensation, it's the negative boil?
Yes. And what would be happening here in this part? If we're going from liquid to solid, what do we call that, going from liquid to solid? Freezing, right?
Yeah.
Q for freezing would be negative this. Just the opposite of melting. So I don't remember if I have a problem up here about freezing, but yeah, if you're dealing with freezing, then you know how much energy it takes to melt a solid. Just use the opposite amount of energy to freeze the liquid.
So then shouldn't it be Q condensing on that one?
Yes, I said freeze, oh my gosh.
Yes,
I'm sorry, I apologize. That does not help. I'm putting the wrong word up there. Yeah, this is Q of condensation. If I put C-O-N.
There we go. Yeah, because I was a little confused.
I'm sorry.
Delta H fuse for freeze?
Yes, yeah. And we can put that up there too. Q for freezing equals negative heat of fusion. Fusion is for melting, and freezing is the opposite process, just with a negative sign in front of it. All right, so let's do that. Okay, there it is. So if we had, and this is, everything is given to us, if we have 0.44 moles of steam, we have to use this formula right here. The Q for condensing that steam would be negative, what number? 40.7.
40.7.
Yeah, it's the same amount as boiling, but with the opposite sign, negative 40.7 kilojoules per mole. And we know the number of moles, we don't even have to convert for it, 0.44.
So why do you need the
We're assuming that there's no temperature changing here, so if it's condensing, we assume that it's at its boiling and condensation point. The boiling point and the condensation point are at the same temperature, so you don't need to worry about the temperature. In this problem, just wait. Okay, so that times that is what? I think I have it up here.
Negative 18.
Negative 18 kilojoules,
Yep.
which would be negative 18,000 joules.
Yes. Yes, it would.
Now let's try one that's not water. You try this one.
Yes, you did, I think.
What's that? Yes, you need moles.
Whenever there's a gram, do we have?
Now, you have two different equations. Well, we have really 4 equations from this. But remember, before we were using this thing Q equals MC delta T. For that one, you have to use the mass. But when you have these, you have to use moles. So make sure you keep them straight. And as always, I'm giving you the equations on the test. Just make sure that you use them correctly.
Yeah. Haha.
For one kind of change, phase changes, you have to use moles for your quantities. But for temperature changes, you have to use grams. This is a phase change, so you're stuck using moles. That means you're given grams, you have to convert to moles. Do you need a periodic table, or do you already know the molar mass of carbon, hydrogen, and oxygen?
I already know.
You know it, come on.
No.
What's carbon? 12. Hydrogen,
1.01. 16!
oxygen 16. So you've got all these. Go ahead, I'll wait for you.
Okay, the answer kind of correlates. You don't number it.
Find somebody nice around you and talk about it. I hear some of you talking. That's good. I want you to. Oh, Jennifer, you can't find anybody nice around you? Sorry.
Yeah. I got the same thing. Do I pick the 2 of them? Or just 5.7? Carly is 5.78. Hopefully.
Okay. I'm trying to listen in and overhear your conversations. I'm hearing this kind of thing. I heard several people come up with the right answer. Heat of fusion of ethanol is given to you. It would have to be given to you. The number of moles, you had to convert to find it, but it was 0.15 moles. So just multiply those two together. And so this is not very much, 6.9 grams of ethanol. Is that a big mass? It's a tiny mass.
Yeah.
That's the mass of probably 2 dimes of ethanol. This tiny little, just a few drops really of ethanol. And you want to boil it. Well, it takes a lot of energy to boil a liquid. And so that would take 5,800 joules, which is also known as 5.8 kilojoules. Just that time day. Anybody have any questions about that? Okay, now I only have one more, but it's not very nice.
Oh, jeez.
You ready? What could I throw at you?
The 2 formulas combined.
Yeah.
Go count.
Don't look at that.
It's 10. Sorry.
Oh man.
This was a real stump.
What? And we could. Let's take a look at this example.
Okay.
I want you to see how to do this. Now you already saw the answer if you were looking. How do we get there? What do we have going on in this problem? We start with ice, and what do we end with?
Water.
We end with liquid water, but not just on the other side of that phase change. It's liquid water at 50 degrees. So there's really 2 different things we have to do. We first have to melt the ice to get it to liquid water. Then you have to take the liquid water and heat it from 0 to 50. Can you do that all at once? No. You've got a phase change and a temperature change. So I need you to know that when you have a phase change and a temperature change in the same problem, you really have to do 2 problems. It's like 2 in 1. You have to find Q for the phase change, Q for the temperature